to talk about. And here on the Q&A this week, we have just a great guest. I know when I announced this, a lot of people said, "Oh, wow, you have Dr. Phil on." So let me introduce you to Dr. Phil Klotzbach, the forever young Dr. Phil Klotzbach, joining us here. Phil, when Dr. Bill Gray introduced me to you and was so happy that he finally had met the guy that was going to take over the seasonal forecasts. How long ago was that? I mean, because you don't look any different, so it seems like it had to have been just a couple of years ago. But I know it was a lot longer than that.
Yeah, so I went out to Colorado State in 2000 to go to graduate school. So it's
Hmm.
been a quarter of a century at
Yeah,
Colorado State.
yeah,
And so
it's amazing.
he and I co-authored the seasonal forecast through 2005, and then I took over as lead author in 2006. But there's definitely a lot more gray in the sideburns these days
Yeah.
than
So
when I started 25 years ago.
yeah, it had to have been this had to have been 2000 or 2001. I remember because I remember you had just come to be part of his team there, part of the program. Really, it's amazing. All right, so Phil is famous, of course. You know his name because he leads the team at Colorado State that makes the seasonal forecast. Of course, that science was created by Dr. Bill Gray there back in the, I guess, starting when did the idea start? In the late 70s? Was the
Yeah,
thinking to around 1980, something like that?
Yeah, so the first seasonal forecast came out in 1984, but it was
Right.
definitely kind of like going around in his head in the early 1980s. And it's interesting. He had a visitor from Australia, and his name was Neville Nichols. And so Neville was doing seasonal hurricane forecasting, or started to come up with the idea of season tropical cyclone forecasting for Australia.
Mhm.
And he was visiting Bill Gray, who was doing kind of the same idea for the Atlantic. So they kind of got to talking about it and talking about El Nino and La Nina and how they relate to tropical cyclones. And so, yeah, so CSU, his first operational forecast was 84. So this is the year number 42 of doing the seasonal hurricane forecast. So hopefully we've improved the methodology a little bit since 84. We got a lot more data and a lot more technology than Dr. Gray had when he started. But I think it's really a testament to his brilliance was that he was able to do all this stuff with marginal computing power. Now it's a lot
Yeah.
easier, a lot more straightforward to kind of build these models and look at a lot of things that he certainly just didn't have the ability to do back in the early 1980s.
Yeah, I was just talking with an old colleague, just we were exchanging texts about somebody sent me a video. A friend sent me a video of a newscast I was on in 1985. And in 1985, we were animating weather maps, and the machine was called a Dubner, and the Dubner had 16 megabytes of RAM. you know, and no, we were animating weather maps on TV with 16 megabytes of RAM. So people back then knew how to be efficient with their what computing power they had. So how do you feel about your seasonal forecast at this point, based on what you're saying? We're kind of right at average in by many metrics, right?
Yeah, that's right. So, I mean, as you mentioned before, we're getting close to the climatological peak of the Atlantic hurricane season. And while the Atlantic hurricane season starts June 1st, ends November 30th, it really is mostly August, September, and October on average. And really is, about effectively 6 months, but there's really 3 months where you get most of your storm activity. And so
Hmm.
Bill Gray used to ring a bell every year on August 20th,
Hmm.
signaling the active part of the hurricane season. I saw you guys covered that on Fox, which is awesome,
Yeah.
covering his bell ringing that he did every year, because that's really when the season ramps up. And kind of why the season ramps up then is that historically early on during the season, the shear is fairly low. So the change in wind speed and direction with height that can often weaken storms or prevent their development is fairly low in, say, July, especially, and really when you get into August. But usually it's too dry, the air is too stable. You get a lot of that dust off of Africa. Water temperatures are still fairly cool. And September 10th is kind of like the perfect match where you have still the shear fairly low, but the waters are warm. So the shear will start to pick up around September 1st, and it really starts to escalate as you get later in September, especially in the eastern part of the Atlantic. Whereas the sea surface temperatures continue to warm up till around October 1st. So a year like last year, which I can obviously talk more about if you're interested,
Mhm.
was a very unusual season in that we ended up hyperactive, but we had that massive 5 week lull during the middle, where I felt like a complete idiot because we had forecasts, no had forecasts, everybody had forecasts, one of the biggest hurricane seasons you're ever going to see, and we went through 5 weeks with the least amount of kind of aggregate hurricane activity since 1994. Then we followed it up with one of the busiest ends of the season on record. And one of the reasons why the end of the season was so busy was because the Atlantic was so dang hot. And we had a borderline La Nina, cool neutral to weak La Nina. The shear was low pretty late, so we were able to get some storms even off of Africa late in the season. Normally, by the time you get to early October, you get storms, but they're more in the Caribbean. You don't get them right off Africa, whereas where last year we had two, and especially one very significant hurricane in Kirk late in the season. And right
Yeah.
off.
But of course, the big ones that we all remember from last year both formed either in the Gulf or in the Caribbean. So let's take a look at what's going on out there right now, and then we'll no doubt trigger some questions. And what's going on out there right now is really complicated, and we have kind of pluses and minuses that we can see in the models and in the data that we have. So here is the development area. It's called Invest, a system now called Invest 91L. It's that very arcane numbering system that the Hurricane Center uses that was never designed for normal humans. It was all internal numbering, but now, of course, everything is public. So we're stuck with it. They estimate 25 miles per hour. All these are just estimates based on the satellite, and they estimate 10, 11 on the pressure. And they have this huge potential development area because it's really uncertain when it's going to develop. But they have 60% over the next 2 days, which kind of surprises me, and it's moving very slowly. So they say 60% in this area here, and then 90% somewhere in here that it becomes a depression. A depression just means that it gets a closed circulation. It doesn't say anything about how strong it is or anything, but the idea is that it is likely, very likely, to develop to some degree. Now, the degree is the big open question here. So let's look at it right now, and there's a couple of things to notice here. One is that there you can see the circulation. Okay, that's with the quasi disturbance, let's call it. And you can make out that the winds are going like this up here and the winds are going like this down here. So you have some sense of a circulation, but it's kind of spread out. You can also see that it's part of a line here that is always out there. It's called the intertropical convergence zone. And the question is it going to break off from that? It has to break off from that and exist on its own if it's going to be a disturbance, and the computer models indicate it is. And what that line is, it's the dividing line between the tropical air to the south, and here you see it feeding in here like this, and the dusty air to the north. And I'm going to ask Phil Klotzbach in just a minute if he doesn't think the dust is hanging around longer than it used to. I used to say dust season ends about the middle of August, and here we are into September, and we still have some pretty significant dust and dry air out there. But in any case, there's the system. It's going that way toward the islands, more or less, and it's got to push that dust enough away if it's going to develop the thunderstorms that will allow it to become stronger. So let's see what the model does with this. This is the European model from earlier. And there you see you have this broad kind of circulation and a cluster of moisture there that's part of this kind of extended area there. It kind of sits there all the time. All right, and look in the upper left, that's your date and time. There we are today. And watch as we go forward in time. Here we go. Over the weekend, we get a bit of a circulation there, and then it gets near the islands in about a week, according to this model. This is just one possibility, but a number of the models are sort of agreeing with this general idea of this trajectory now. And you notice we don't have a very strong system here. It's got a circulation, but it's not a lot. And boy, there's a lot of dry air all kind of wrapped around it in every which direction. Is it the dry air that's holding it back? Probably, because as Phil was talking about, the shear or the hostile upper winds don't look like a problem if it stays south like that. So probably dry air is what the hindrance is, at least for a good while on that trip. If it becomes a hindrance and it can't pull enough moisture together, develop big enough thunderstorms to push the dry air out? That's the big kind of open question. All right, so here's something, Phil. I don't know if you've seen this. This is something we have. We just started on Fox Weather. What we do is we take the European, what are called ensembles, the multiple runs of the European, the multiple runs of the GFS, and the multiple runs of the Google DeepMind AI model, and do a kind of a heat map of where they're concentrated. And this doesn't say anything about the strength of the storm. This just says, will it develop? So you can see the highest chance of development is in this area in here, where it's up to about 50%. And then out here, there's less. Okay, there's less for a couple reasons. One is because the possibility of the location kind of spreads out. Some go up in here, some go down here, but also a number of the possibilities die the storm out or weaken it significantly. So now we have big question marks in here. The bottom line and the message from this is that indeed the odds favor this system heading in the direction of the Caribbean islands about 6 days, 5 to 7 days from now, somewhere in that range. The afternoon Google AI model actually moves it faster, takes it there by late Tuesday. Others more like Thursday. So that's the message. Exactly in what form, we don't know at this point. And then the question is, what's going to happen after that? Let's assume that we have a storm in this area or something. Look at this upper low up here. This is a low, and this is going to create some kind of perhaps hostile upper winds over it that might push the dry air into it, might be a negative factor. Also could slow it down because that affects the steering right in there. And then we have this high over here. And what's going to happen there? Is it going to get caught under there somehow and end up over in here? Or anyway, things get very messy in this time period. We're talking a week from now up in there. So big question marks. And yes, you can go online and look at models from earlier today that shows storms coming to Florida and so forth, but it's here or there or whatever. We don't really know when storms are moving slowly like that. It's a big open question. All right, Phil, any thoughts on all that?
Yeah, well, you did a great recap there of what we're looking at. So this one is it's dicey, as you mentioned. The models are kind of all over the place. If you look at kind of like you said, like that. So you showed like the European Center, the operational run, and so the operational run, the European. So it used to be we ran what we called like the operational or deterministic run was run at a higher model resolution. So it was basically like more grid points, so more computational power, but it was probably like a better kind of like best estimate. Whereas now,
yeah, the one we used to call the Euro, the one that
the Euro.
everybody
So
knew
now
as
there's
the Euro.
Now the
Euro.
ensemble. So there's basically 51 members, and that's one of 51. That is
yes,
fun.
right.
And if you look at the ensemble, there are some members that do nothing with it, basically kill it, and there's others that have like a really potent hurricane out of it. And so, I think this case it definitely highlights the uncertainty. So shear probably is not going to be a big deal, especially given how far south it looks like it's going to be tracking. If it tracks farther to the north, you had a nice graphic earlier where you could kind of see like an upper level low that would definitely really kind of have sheared it and given it quite a bit of trouble, especially if it was trying to go north in the short term.
Right.
So really kind of the big question is going to be, is when there's a lot of shear, then the odds of dry air getting mixed in are a lot higher. If the shear was low, maybe not so much, but there is plenty of dry air around. So that's one of the kind of the big questions, I think, with this particular system. Like you mentioned, the last couple of weeks, really it has not been shear. And it's been an interesting year. So if you look at, say, like aggregate measures, we use accumulated cyclone energy, which is storm intensity and duration. So a storm like Erin, which is a long-lived major hurricane, generated a ton of ACE. But the rest of the storms have been really kind of short blips. But if you look at ACE for the year, we're about average. We're a little below normal for hurricanes. And again, the more days we don't have a storm, we could fall further and further below normal. But we saw last year we were below normal around September 22nd, and we caught up and went hyperactive by the end of the season. But one of the things I think has been holding things back is it's been fairly substantive. There's been a fair amount of dry air that really has been squelching stuff so far. Now, if we look longer at kind of some of the model projections, we should start getting more air going up over Africa and Indian Ocean. There's signals of a couple of really robust African easterly waves coming off that probably will also help moisten up the main development region, or kind of the main region where storms form in the Atlantic. So probably as we get longer into the future, the stability issue is probably going to go away. And honestly, and it's not the same as last year, but last year we saw similar kind of stability challenges. The Atlantic was super hot last year, but the atmosphere was very stable. Even in early to mid-September, we had a couple of systems the National Hurricane Center was monitoring, had almost no shear over them, but they just couldn't get any thunderstorm activity. So
Right.
as you mentioned, it is kind of bogged down in this intertropical convergence zone, which is kind of this area where low level winds converge, and you get these areas of thunderstorm activity. And the models are kind of showing it probably will start to move the last couple of days hasn't moved much, and that isn't, the storm needs to move a little bit to kind of get its circulation going, and also kind of not so cool, turns up enough cold water, it kills itself. So I think now the storm is starting to move. I think the odds do favor it to form. Obviously, you pick your ensemble member. You can go anywhere from something that dies and does nothing to something that's a Cat 4 or Cat 5 hurricane. So take your pick. For whatever reason, the AI models have been a little less bullish with this particular system than the kind of more like the full physics models. The
Yeah,
AI
they're more
models
bullish with the one after it, actually, although they don't, they do a lot of different things with it and generally take it north, but they actually
yeah. So
they get a little more excited about
depends.
that.
I mean, it just kind of depends on, AI models have done better with some storms this year. They've done worse with
Right.
others. So it's just because it's AI doesn't mean it's better or mean it's worse. So certainly something I think that bears watching, especially now that this track has shifted south. That potentially could at least pose a threat to the Leeward and maybe even the Windward Islands, depending on how far south it goes. And then obviously what happens after that remains to be seen. Where it would track. Right. Obviously, we don't have great. Until we get a well-defined center of circulation, the track is unclear, and we saw that certainly with Hurricane Aaron a couple weeks ago. For a while, looking, well, maybe it'll end up hitting the U.S., and then once it got a well-defined center, you saw the models kind of converge and say it was going to actually pretty much do about the ideal track if you're looking for, if you're going to have a Category 5 hurricane and a big hurricane, kind of like perfectly split the gap. So there were some impacts, but nobody was massively impacted. Obviously, you run that storm a couple hundred miles farther to the west, and that would be a huge problem. And I can tell you, I was on Mount Washington in New Hampshire on August 21st, and so Mount Washington is nowhere near the Outer Banks. And I can see on the southern horizon cirrus clouds from the outflow of Hurricane Aaron.
Was a
just
giant,
tells you how massive that storm was.
Really, exactly. All right, Jordan Overton is in the New York headquarters, and he's monitoring our feeds. And Jordan, do we have questions from our viewers today?
Yeah, we have some questions coming in. I think the biggest question, I'll put up the graphics so that you guys can look at this together. It's really from Florida. I've got questions about, should we worry in Miami, up in parts of Florida? Is it going to curve out? Some people talking about in. On TikTok, some of the same things. Is it going to recurve quickly? So that's kind of the biggest question, is that. I'll put up the graphics in case you guys want to talk about that.
Yeah. So, obviously here in South Florida, this is what we want to know, 100%. And we don't know the odds of it affecting South Florida or affecting the Carolinas or going out in the ocean or dying out. I would put it about equal at this point, because it's just too far away. We have the technology now that we can show forecasts 2 weeks or more in advance. That doesn't mean we can actually forecast in all situations that far in advance. But because, like I was showing, so here we are, this is like next week. Okay. So here is the system nominally down here in the Northern Caribbean. And there's this high sitting right here. Okay. And that's a pretty good circulation there. So how is that going to affect this? If this is up here instead, that's a whole different thing than if it's down here somewhere and it kind of comes in like this, right? There's just all these possibilities, and that's assuming that the high is actually there, which it probably isn't. It's probably a little bit different when we get to a week from now. So I wish we could answer that question. And Phil was talking about the differences in the intensities on the different ensemble members. If you look at the actual intensity models that they specialize in trying to figure out how strong a storm is going to be in advance, it's anything between dead, like 0 or 20 miles an hour or something, and Category 3. So it's this huge range now. And I think the other really important thing Phil pointed out was, whether it's an AI model or it's a European or it's a GFS model, they're never going to do well when a system is not well defined. So as I say, if a system is undeveloped, just developing, or moving slowly, forecasts are subject to large errors and are likely to change.
If
That's
I
just
could
a
just,
good
yeah, Brian, if I could just
forecasting
jump
rule.
in, there's also a
Yeah.
lot of comments here about Irma. There's a lot of Irma comparisons of, is this Irma 2.0? I've seen a couple of comments about that. So maybe you guys can speak to, is this similar or differences, that kind of thing.
All right, Phil. I mean, you
Yeah,
you were around for Irma. You remember Irma?
I was definitely around for Irma.
Yeah.
I probably have several of my gray hairs are from Irma.
Yeah.
Uh, I mean, at this point, no. I mean, we don't. None of the
Right.
models are showing this as being anything like crazy like that. I mean, again, obviously, the system hasn't even formed yet, so today's kind of really an awkward day to talk about it because what we have,
Yeah.
like, depending again, take your pick. If you want to have you can look at, I can show you plenty of models that show nothing, and I can show you models that look scary.
Right.
But I think really right now, I mean, the odds of it hitting any place are low. I mean, you look at these probabilities are very low. And as Bryan mentioned, it's because over time, the odds of this thing going anywhere are just very spread out because one, it may not develop at all. And if it does develop and becomes a robust storm, who knows exactly where it's going to go. So there's just a lot of uncertainty. I mean, obviously NHC is quite confident it's going to become at least a tropical depression. They gave it a 90% chance, which is, quite confident, and pretty much all the models develop it at least a little bit. Then it just remains to be seen where it tracks, how all these other moving pieces come into play. And again, because it's probably going to be a fairly small circulation at the start, it's very susceptible to ups and downs. Obviously, when you get a storm like Aaron a couple of weeks ago, started off pretty small, it blew up, and then as you got later in its life cycle, it was absolutely enormous. So you would have had to hit the storm with a massive hammer to get it to do anything. And even when it was in a super conducive environment, it intensified a little bit, but it more went into pressure drop and growing the size of the storm than actually into spinning up the winds. So, right when it's a small storm really getting going, it's just not a lot that we can say. So I would say, at this point, something to watch. But obviously right now it's just a broad cluster of thunderstorms. It definitely looks a lot more conducive, or looks much better than it say did last night. If you're looking for the storm to form, last night it was very convectively starved, but could ingest dry air and weaken again. But again, most of the models do intensify a little bit. So, I think that's about all we can say about this particular area at this point. Is just, something to watch. Certainly, obviously, NHC is quite confident that it will develop, but how much it develops and where it goes, I think still just remains to be seen. We shall see.
Yeah, and remember that with the Irma, just to compare it to Irma, Irma was a very powerful hurricane in here, right? So it went through the northern islands there, Barbuda and east of Puerto Rico. I mean, as a super strong Category 5, but in this area here, it was already super strong. There's no indication of that. I don't remember the atmosphere around Irma, but I can guarantee it wasn't dry like this. Do you remember how far east Irma actually
Irma hit the
became
ground
strong?
running pretty quickly.
Yeah,
It was really
that's what
getting
I thought.
cranked up, and it was small at its start. And it went through a bunch of IOR replacement cycles early on,
And
and
grew.
grew and got. By
Yeah,
the time it got to the islands, it was large and obviously super intense. So obviously we're looking at something that hasn't even formed yet. So I mean, at
this is
this
a
point,
whole
yeah,
different
it's
scenario.
a whole
Yeah.
different ball game. So we'll see. But I mean, I can tell you when I was talking with Bryan, I think you asked me to do this last Thursday.
Mhm.
And I think when you asked me, I was like, well, there's probably not going to be much to talk about because at that point, the models really didn't have much of even of this thing going. So things can change rapidly this time of year just because there's a reason it's a climatological peak. And so things that look kind of anemic, suddenly all the models say, hey, this is actually something we're going to be interested in. So, really now's the time to just, pay attention. But again, this is a lot of speculation on a system that's really kind of just getting going. So even if we were doing this discussion like yesterday evening, would have been like, well, there's hardly any thunderstorms there. So once
Yeah.
NHC declares an invest, that means obviously they're getting much more intrigued by the system as to its potential, and obviously 90% is a pretty high chance that at least it'll become a tropical depression at some point.
Exactly. All right, Jordan, what do you have?
Yeah, so this is more of a question for Phil here. And it's out of the key predictors that are used for seasonal forecasting is West African rainfall as a proxy for easterly wave activity still considered?
Yeah, so that's a really good question because we actually used to use West African rainfall as one of our big predictors of seasonal hurricane activity. When you got a lot of rain in the Sahel region, so just south of the Sahara Desert, that was kind of a proxy of basically the strength of African easterly waves, which are these strong thunderstorm complexes, which are basically what we call kind of the seeds of a lot of Atlantic hurricanes. And often they're also the seeds of eastern North Pacific hurricanes if they don't form in the Atlantic. But, we stopped using rainfall as a specific tool just because the data was a little bit marginal that we were getting from Africa for rainfall. So what we use now is upper level winds over basically West Africa through East Africa. When those upper level winds are stronger out of the east, that's typically associated with what we call a robust tropical easterly jet. And when you have that robust tropical easterly jet, that tends to be associated with basically higher amplitude or more vigorous African easterly waves. So typically the number of African easterly waves year to year doesn't change all that much, but some years they're super vigorous. And if they're really vigorous, that tends to mean that their odds of development are just higher. Certainly, you can get vigorous waves that do nothing, and you can get kind of anemic waves that spin up. But in general, a more robust African easterly wave or strong thunderstorm complex coming off Africa has a higher chance of formation. And so that's what we use now for our seasonal forecasts. Dr. Gray used to always say, if he had a grad student, he wanted to get a grad student to go to Dakar, Senegal with the rain gauge, because if it rains hard in Dakar, that's the waves you need to watch. So, and it does work out pretty well a lot of the time. Now, one thing I did want to point out is, so last year during kind of the lull that we had, there was a lot of discussion about African easterly waves coming off very far to the north, places like Mauritania, Western Sahara, where they basically were just coming out super far to the north. And at that latitude, if the water's too cold, then it's really dry. This year,
it rained in the Sahara last year. I mean,
yeah,
that's
exactly.
how far north
and it
they
wasn't,
were.
and so that was an issue in August. Once you got to September, there were other things that prolonged the
Right.
lull. But this year, the African easterly waves really haven't been coming off super far to the north. The current wave is actually fairly far to the south.
Right, exactly.
It kind of came off even. It was about like 11, 12 degrees north where it emerged off of Africa. So like the current wave is at like 13-ish north, which is fairly low latitude. So the quiet period that we've had the last 7 days or so hasn't been due to waves coming off too far to the north. And the next wave coming off behind this, well, there's one in like 4 or 5 days. It looks like it's probably DOA, but the one behind that looks much more interesting. The models are pretty bullish on that developing. But we'll see, obviously, at that, we're looking at something that's probably over Ethiopia right now. So but I have to say, now that I can kind of put on my philosophical hat, things have really come a long way in the last, say, 25 years. So, I've been doing this for 25 years. Brian's been doing it even longer than I've been doing it. And like things have changed a lot. So, now we have these, I can go look at like a 15-day ensemble and say, okay, here's a wave that might come off Africa in a few days and the models are bullish on it or they're not. We used to not have any of that. And especially one of the big things that we look for at CSU. So our group at Colorado State, in addition to doing seasonal forecasts, does 2-week forecasts. Starting in like early August, we update it every 2 weeks. And the reason we do the 2-week forecast is because you can have a busy season with a quiet period. Obviously, last year is a great example. Or you can have a quiet season with a busy period. So we're trying to kind of highlight where during the season we expect these peaks or ebbs and flows. And also, once we get to 2 weeks, you can start to say, it looks busy and it looks like it's all in the open ocean with no impacts to land, or it looks busy and it's going to be in the Gulf or a big ridge and it's going to be pushing stuff further west. So you can start to highlight areas that may be impacted. Also, the Climate Prediction Center does week 2 and week 3 global tropical cyclone forecast probabilities. So that's another really good resource if you're looking for kind of that sub-seasonal scale. And this is stuff that we just couldn't do 25 years ago. And one of the big things
what's your latest 2-week forecast, Phil? I meant to look that up.
We went average for the 2 weeks, and that's primarily so our 2-week forecast verify off of that integrated metric, accumulated cyclone energy. And so, it's based a decent amount on both the current system developing, at least to a certain point, and then also potential activity behind it. So this current week and a little bit next week, the shear isn't optimal as you get farther north in the Atlantic. So in the deep tropics where this storm is currently located and where it's forecast to go, if you look at kind of the model diagnostics, the shear is fairly low. So shear is not going to be a big issue with this storm, at least for the next few days, most likely, unless it tracks farther to the north. But as we get later into September, the shear looks quite conducive over the basin. We also look at the low-level winds that are being forecast, and there's a lot of basically low-level west winds blowing. So basically weaker trade winds in the deep tropics and weaker western or weaker. So basically you have an area basically of low-level spin kind of in the main development region, which is usually very conducive to get storms to form. So we do expect as we get mid to late September, the odds of formations coming out of Africa or coming off of Africa are going to go up. And if you look at the Climate Prediction Center, they're certainly also getting bullish on development as we get mid to late September timeframe now. Once you get past late September, unless it's last year, the odds of development right off Africa go down. That's typically when your storms are more likely to form in places like the Caribbean. And given the Caribbean is very, very warm right now, and we have cool neutral borderline weak La Nina conditions at this point, that tends to result in lower shear, also maybe perhaps a more vigorous, what we call like a Caribbean gyre, which is this broad area of low pressure that develops in the Caribbean. That can spin up storms. Sometimes it spins up a big sprawly mess. Other times it spins up a Helene or something, obviously a lot more potent. And obviously that kind of remains to be seen. But certainly the conditions overall look like they're going to be getting more conducive over the next couple to 3 weeks. So, certainly this is obviously we've already talked a lot about the current system that the Hurricane Center has, but likely after that, there are going to be at least a couple more robust candidates coming off of Africa before we shift our attention farther to the west. There's even some indications, maybe something to watch, keep our eyes peeled, and the Climate Prediction Center has this as well, more in the West Atlantic in a couple of weeks as well. So certainly lots of stuff to watch. This is the climatological peak of the season. So we don't think the season's going to be a dud. I don't want to verify a forecast September 4th, but we certainly don't think we're going to be seeing a colossal forecast bust overall, given kind of the large scale conditions. But, obviously, if we talked September 20th last year, Brian, I probably wouldn't have said, I would have given you very low odds of a hyperactive season. So, shows what we know about seasonal forecasting.
But the macro of last year of the ocean temperature being very, very warm was and the indicator, it was such a key indicator. And this year, as you said, the Caribbean is plenty warm for sure, and the Gulf is, depending on exactly you measure it, it's like near record warm. So when we get to the time of the season later this year, late September into October, when storms normally form in the Caribbean and Gulf, having all that extra energy, plus we might be pushing toward La Nina, which is conducive to storms developing, we would expect a backloaded season. I mean, that's what I've been saying. I think that's what you've been saying, more or less, right?
Yeah, and typically also, what's kind of held back this season has been more the stability. It's been a little too stable. Just on average,
dry air, Sahara dust and dry air.
More, your instability gets it gets more unstable throughout September. So
right.
Those things that were kind of holding, and we saw that a lot last year too. Like last year, obviously the waters thankfully aren't as warm as they were last year, but they're still running, I think, 6th warmest since 1979. So still plenty warm for gnarly storms. And really, as you mentioned, like in the Gulf is obviously, as you know, plenty warm to support gnarly hurricanes any year. Obviously, it's just a matter of getting a disturbance into the Gulf with relatively low shear, and sometimes dry air can be a big issue there as well. So obviously that remains to be seen, but again, overall the large scale looks fairly conducive coming up, with more rising motion over Africa and Indian Ocean, kind of invigorating the African easterly waves and reducing the vertical wind shear over the Atlantic as we again approach the climatological peak, which is September 10th.
Yeah. All right, Jordan, what else do you have going?
Yeah, so here's an interesting question coming in. Is the increase in volcanic activity that is being reported something that is factored into models, or do you only see effects in hindsight?
So typically the only volcanoes that really would impact, say, sea surface temperatures are ones that erupt in the tropics. They can sometimes get the aerosols and everything can get kind of trapped in the tropical belt and can cause pretty significant sea surface temperature changes. But that's be really, really big volcanic eruptions. So really the last one that caused a significant change in sea surface temperatures globally would have been Mount Pinatubo back in, I believe the eruption was December of 1991. And that was shown to change sea surface temperatures, which then changes hurricane activity in the Atlantic. It changed activity in the Pacific. Most of these other volcanoes, even though they have impressive eruptions, just don't have the magnitude of basically the sulfate that's are emitted from them to cause significant impacts to like global tropical cyclone activity. But certainly, if you go back to like, oh gosh, my dates of volcanic eruptions are not as good as I think Krakatoa was 1883. I mean, you can get these monstrous ones that likely, obviously, we don't really know what tropical cyclones were doing in 1883, but those ones definitely would play a role. Obviously, most of the ones we get just don't have quite the magnitude of the eruption to cause significant changes in the sea surface temperatures, which is really kind of how we typically see volcanoes and volcanic impacts on hurricane activity.
So what was Tambora was 1815.
Yeah.
So that which cooled the whole hemisphere,
Yeah,
right?
yeah. There's the infamous year without a summer in New
Right,
England.
in
And all
New
that.
England.
So,
In New England,
so
yes.
yeah. So, but again, those are like really monstrous volcanic eruptions.
Right.
So there was one a couple of years ago. I forget the name, and I remember checking with colleagues because it was a pretty big one and saying, how much, basically, what was the sulfate load, and it just wasn't up to the magnitude that you would need to cause significant changes. So there's actually been interesting. I think there was one where there was actually like a hurricane making landfall while there was a volcano erupting over Hawaii, and there was some interesting discussion about what was going on there. But I think the volcanic eruptions that we've seen recently haven't been big enough to cause significant changes to sea surface temperatures. Now, if you're looking to talk about changing sea surface temperatures, there's obviously a lot of different factors. You have like the long-term kind of warming trend that we've observed, but you also have really year to year, a lot of it is due to just changes in the low level winds. When you strengthen the winds over an ocean, basically what that does is it causes more evaporation off of the ocean surface. It can cause significant cooling. And really where you see that best is in a hurricane, right? Like if you look at sea surface temperatures, it started to fade a little bit, but if you look at sea surface temperature differences a week ago, you saw a huge cold blob in the Western Atlantic where Aaron had been.
It's still there. Yeah.
Yeah, it's still there. It's starting to weaken, but it's still there.
Yeah.
But interestingly enough, when you have that really big, obviously very powerful low pressure in the subtropical Atlantic, on its southern flank, you had basically anomalous flow, or basically low-level westerly anomalous flow in the Caribbean, which basically meant we had no trades in the Caribbean, and the Caribbean sea surface temperature spiked.
Right.
You could say that because of the track that it took, it could potentially pave the way for another hurricane later on out of the Caribbean, just because of what it did to the circulation. So, where we always emphasize, if you see sea surface temperatures change in a short amount of time pretty dramatically, it's likely due to either stronger or weaker winds blowing across the ocean. And so again, you get these cold wakes that will happen when you have a hurricane track. But obviously, given Aaron was over a week ago now, if the system were to happen to track right over where Aaron went, by the time it got there, given it's moving at a snail's pace, probably that cold wake would be almost gone. Usually it's about 2 to 3 weeks for it to kind of basically fade out. So still remains to be seen, but if you're going to see big sea surface temperatures in a short amount of time changes, it's due to these changes in the winds. So for example, last year, the Atlantic was really hot from about January to March. The winds got pretty strong. We had a pretty strong subtropical high that really freshened the winds, and we went back to almost near normal for sea surface temperatures. And then since say about July, the winds have been quite a bit weaker, and the sea surface temperature anomalies in general have gone higher. So when we talk about anomaly, it's a difference from average. So we went from kind of a little bit warmer than normal to now we're back up, not quite the 2023 and 2024 territory, but had we not had those 2 seasons, we'd be talking about how blasted hot it was there right now.
Yeah. So to answer the question directly, in a way, yes, the volcanic eruptions, if we had one that was going to affect tropics, feeds into it because the temperature of the ocean feeds into the model. So it affects the temperature of the ocean, and then the models know about the ocean temperature because they're coupled models between what's going on in the ocean. The fancy models are coupled models. They know what's going on in the ocean and how that feeds into the storm. Okay, Aaron, living in the past where we're talking about Aaron.
Complaining people with hurricanes. That happens.
Yeah, Jordan, go ahead.
All right. So our TikTok viewers, they are asking about the Pacific. There's some questions about the moisture coming into the Southwest. There's some questions about people traveling to Hawaii in about a week, and they see the cone basically pointing at it. So I'll pull up the graphics, and maybe you guys can talk about that. Some questions from TikTok.
All right, so in the Pacific there, we have Lorena and we have Kiko. So Lorena is up here, and it's being ripped apart. And really, the issue with Lorena is the moisture going into that's moving across Mexico, Sonora State in Mexico, and into the southwestern U.S. And Kiko is really an amazing storm. Take a look here. 130 miles an hour is the 11 a.m. Eastern time estimate of the intensity, but it's kind of an annular hurricane. An annular hurricane doesn't have these bands sticking out. It's more like a donut, and it survives longer with hostile conditions around it. How often do we get annular hurricanes like this, Phil? I mean,
Yeah,
it
I mean
feels like
it's
a Western Pacific thing more than
so
an
so
Atlantic
I was
thing.
looking at this because I thought this might come up today. Is so typically actually they're most common in the Eastern North Pacific, the Atlantic and the Western North Pacific, not very
Is
often.
that
But
right?
this
Okay.
is so it's kind of like, I'm not a hardcore like hurricane dynamicist, but basically what you get more mixing between the eye and the eye wall. So it'll kind of you'll get these big eyes. They call it an annual hurricane. I prefer a donut hurricane because one, I like donuts and no one knows what annular is, but most people know what a donut looks
Yeah.
like. And so because these storms tend to be basically kind of more robust to, if you were to, so usually they're in fairly low shear environments, and you can see that right
Mhm.
now. I'm pointing at the screen like you can see it. But anyway,
Yeah.
they tend to be in more of these low shear environments, and you can see it's pretty symmetric right now. So
Mhm.
it weakened a little bit overnight. It went through one of these eye wall replacement cycles where basically the inner eye will collapse and you'll get an outer eye that will replace it. There is some discussion that it will become an annular cycle, and I'd say it already kind of looks at least a little bit like that.
Right. Still
But
has kind of a wing on it down here a little bit.
yeah, and
Yeah.
typically, so right now the storm's potent, and obviously as it heads toward Hawaii, you can see the hurricane center is really throttling its intensity quite dramatically. And that, although we've seen a lot of storms approach Hawaii from the east, and they generally don't last very well. And that's because as you get closer to Hawaii, the water temperatures get a lot colder. There's a lot more shear, and there's a ton of dry air as it's
Mhm.
headed that direction. So, the system may look pretty potent, but you can see it's taking it down from 100 miles an hour. I can't see because of where my face is, but I believe it's 70 miles an hour on Tuesday.
70 mile an hour
Yeah, so
tropical
that's a
storm.
pretty
Yeah.
pretty marked reduction in its
Right.
intensity as it's coming along. And again, typically you can see. Okay, so those are your sea surface temperatures, right? That you're showing
Yes.
there.
Yes.
Yeah, you can
Yeah.
see that it's going from yellow to green. And typically, kind of what we talk about with sea surface temperatures is you want sea surface temperatures of about 26 to 27 degrees
Yeah.
is
So in the 80s.
kind of the bare minimum. And once you get into the
Yeah.
green, once you get into the 70s, it's just too cold for these storms. So often they will weaken pretty substantially. And we see that probably the most you can see it in any basin, but in the Eastern North Pacific. So my colleague Kim Wood, who's an awesome scientist, always talks about Eastern North Pacific storms partying hard and crashing hard. And you see them, they really do crash hard. They'll get really strong. Then they'll get north of that, what we call the 26.5 degrees Celsius isotherm. So basically when
Mhm.
it gets into
Right.
colder water, and they die off really, really fast. And you'll see this kind of low level swirl just spinning around. And
Yeah.
just
The question is, I guess, whether the annularness of it protects it for longer over the
yeah,
cold water. But the other thing is, it's a really small hurricane, and even the Big Island is a relatively small island. And for the worst of that hurricane to hit that island, you have to be kind of stupid unlucky,
yeah.
because it just had little angle difference and it misses in a big way. So, Hawaii people need to watch it and be aware of the possibility of some effect, but definitely not worry about having some kind of category 4 hurricane. This is not a Niki. It's not coming from the south.
Yeah,
Uh,
coming from the south is really
that's
if it's going to hit Hawaii
the
hard, it
difference.
kind of has to come
Yeah.
from the south. And I did note the National Hurricane Center is planning on flying the storm. I saw it in their logs. They are going to be flying the storm, I believe, in a couple of days. So they're certainly obviously they're paying attention to it.
Yeah.
They'll be getting the planes in there to get a better view, because you can get a lot from satellite, but getting a plane in there really is
Mhm.
helpful to get more kind of not ground truth, but air truth on what exactly is going on
Yeah.
with that storm.
All right, Jordan.
Yeah, next question coming in. Brian, is there a new cone for hurricane season? Not sure if you guys know much about that.
And the only thing I can think of is not. First of all, the cone didn't change significantly this year. It's the same size. It changes every year because it's based on the average of the last 5 years of errors, National Hurricane Center forecast. So it didn't change much at all. They did, publish. I guess I think it's next year it becomes official. The cone that includes the watches and warnings as the official cone. That's kind of in the works. But other than that, is there any other thing I'm missing there, Phil?
I think you got it. That was what I was going to say. And so the cone is basically based on 2/3 of the last, basically it's 2/3 of the forecast errors at each lead time fell within that cone out to 5 days. So the cone is kind of basically like, here's historically where, 2/3 of the storms would fall, but it isn't representative necessarily of any individual storm. And so that's important to realize too. So with these ensembles that we have, it can kind of help. So for example, when you think about a storm like Hurricane Ida in 2021, formed in the Caribbean, pretty much all the ensemble members were right on top of each other. NHC's like initial forecast and where it made landfall, I mean, it was, I don't forget, but it was like 20 nautical miles. It was like a banner forecast. Whereas you look at a storm, say like Hurricane Ian, there was a lot of more uncertainty in the ensembles where the storm was going to track. And there's just some storms, there's like one feature that's steering it. So maybe there's like a big high pressure and that's what's steering it. It's very well forecast. Whereas other times there's 2 or 3 kind of like little bumps in the kind of the jet stream. So we talk about hurricanes behaving like a pebble in a stream. And sometimes that stream is very straightforward. Other times it's extremely complicated. And that's why it's important, in addition to so if a storm is approaching the US, in addition to flying planes into the storm to measure the intensity, they'll also fly planes around the storm to get better ideas of exactly, where these nuances are. There's really cool techniques by people that are way better at math than I am, where they can basically say like, here's where the model is struggling. This is where the uncertainty is in the model. So we need to measure stuff there. So they'll do that to kind of estimate kind of where your big uncertainties are coming from. They also will launch special weather balloons that actually do help improve kind of tweaking the forecast track. And you think about a storm, especially a storm that's tracking, basically a storm that's tracking perpendicular to a coastline like Milton last year. Obviously, where Milton made landfall was huge. Obviously, had it made landfall 50 miles farther north, that storm surge going into a place like Tampa Bay would have been a whole different story than had it, where it tracked where it did. So there's a lot of cool technology that we use to kind of really kind of fine tune, the pebbles in the stream. And obviously, if this storm in the Atlantic were to develop and become strong, there would obviously be starting to fly that storm in a few days as well. So we'll see. I haven't seen anything posted as of yet, but likely.
Yeah, it's a little far out there right now.
I suspect it's also moving at a snail's pace. So if you remember, Aaron was moving pretty quickly.
Right.
This thing is moving very slowly. It's moved, I don't know, maybe like 50 miles today or something like it. It's really moving at a snail's pace. So, they're talking about it approaching the Leeward Islands by the middle of next week. So it's not going fast.
Yeah. Yeah. So normally you look at those ensembles, and if they're spread out, you go, okay, this is a low certainty forecast, high uncertainty forecast. And if they're kind of all agree, the various models agree, the various versions of the same model agree, it's more certain, right? That usually works. That didn't work for all of Ian, however. There was part of the time that it was very certainly going to Tampa Bay. And then before that, it was kind of uncertain. And after that, it was kind of uncertain. And so this is why you can't look at one model run. You have to look at the variety. But Ian was very, very annoying in that way because the rule of thumb didn't completely work. All right, Jordan?
All right, so our next question. Can you explain the dust stuff from the Sahara? And I pulled up the graphic with the dust that you guys can talk about, but dust from the Sahara.
Yeah,
right,
so Saharan dust can be an inhibiting factor for tropical cyclones. So tropical cyclone, you think of a hurricane as basically a complex of strong thunderstorms. So if you have a lot of dust, you typically have a lot of dry air, and that will squelch the thunderstorm development. Now, typically, as we talked about, June, July, you get a fair amount of dust. This year, the dust actually was fairly low, and some of that was like you do. So the thing is with the dust, obviously, when you have the dust out there, it may inhibit developments right there, but also when you get a very vigorous African easterly wave coming off Africa, behind it will actually bring out dust along with it. So it's not necessarily if you see dust that it means, oh, the season's quiet. 2020 had one of these, had a monstrous dust outbreak, and obviously 2020 had 30 storms, so nowhere near being a quiet hurricane season. And so a lot of the question is, if there's dry air around a storm and it doesn't mix into the storm, it's not necessarily a big deal. Obviously, if it mixes into the storm, that can pose problematic. You will also see years, I believe 2022. So 2022, we went through the entire month of August without any storms. It's the first time since like 97, which was a monster.
That was the Ian year.
Yeah. And so we had an African easterly wave come out in like late August, and it was very dry out there. And it was basically like a sacrificial wave. Like it didn't form, but it moistened up the main development region, the
Mhm.
tropical Atlantic, such that when the next system came off, which eventually became Earl, it was able to get going. And then after that, we had quite a chain of storms in September. And we didn't, certainly the forecast, it wasn't our best seasonal forecast. That was less than what we thought, but we still ended up with 8 hurricanes, which is still an above normal year, even despite having no hurricanes during the entire month of August. So that's kind of how the dust works. It's not a super one-to-one. Usually what we look at is like a seasonal forecast is dust right off of Africa doesn't correlate that well with hurricane seasons just because you get it with African easterly waves. If that dust goes all the way into the Caribbean, farther to the west, that is typically a sign that conditions are not very conducive because that means you have pretty strong low level winds, which tends to mean stronger shear. And so the dust relationship is a little messy. So we don't use it operationally in our seasonal forecast. One, because we don't have really good dust data going back far enough for our statistical models, but also just because the relationship is fairly messy. And we use a lot of other proxies. We look at a lot at wind patterns, which tend to be basically our best overall seasonal predictors are lower and upper level winds. So Bill Gray used to always use just the upper level winds. And the reason why I use upper level winds is because there's big differences year on year. Whereas the low level winds, they may change half a meter per second or a meter per second, so 1 or 2 miles an hour, which back in the day we couldn't measure very accurately. Now with the new better computers, better data, better satellites, we can measure these very small perturbations, and those actually have better skill than does the upper level winds. But unfortunately, Dr. Gray passed away in 2016. But if he were on this call, I'd say we didn't use them because we just couldn't really measure the changes as well as we can now. So that really getting better realizations of how the past looked has really helped our seasonal forecast. Sorry to go off on a little tangent there, but when we have an hour, I tend to go off on tangents.
So I asked you this before. I don't think when we kind of went off in a different direction. Does it seem to you? The dust has just been around the last several years, or how many years? I don't know. It has been around longer in the year. I can remember saying that the dust season is usually over August 15th. And, and I always correlated that in my mind anyway, whether it's true or not, with, well, that's part of when hurricane season normally picks up. And the fact that the dust season declines and the hurricane season picks up, that somehow they were related phenomena. But that doesn't seem to be the case anymore now, because I remember last year we had dust like this into September.
Yeah, and I mean it kind of depends on the year. So like a lot of times people, it's hard because I always fix it a lot on the previous season. So this is what happened last year. But if you think back to 2023, 2023 was like basically it was very climatological season where it really ramped up. Basically August 20th, the bell rang. We had all these storms, and then we got to early October and the season died down. So 2023 was 2023 was kind of a normal season, just more active than normal, but it followed that seasonal cycle pretty well, and the dust was pretty much gone by middle of August. This year again, we're dealing with some kind of sinking motion over Africa that kind of would tend to support more dust coming off. As conditions, I think the tropical conditions become more conducive for promoting upward motion over Africa. Probably that the dust will start to go. So we'll see what happens with this particular system, but given the indications of what's coming behind it, likely, it's not going to be inhibiting things for that much longer.
All right.
And we'll see what happens with this storm. Maybe, who knows?
Yeah, let's see. All right. So yeah, there's the dust, which shows it being below normal.
Yeah.
But that counts the amount of dust, not just whether the dust is persistent. It's a little bit of a different thing. But there you can see where the peak is. The peak is in
June,
and July, and then normally it falls off after that. All right, Jordan, what you have?
So our next question here is talking about, give me one sec, there we go. Question for Phil, based off your initial preseason forecast, is this season shaping out as you envisioned originally, or maybe a little slower?
I mean, certainly right now it's been a little slower than we anticipated, but given kind of what we see in the environment coming up, it's likely to pick up pretty dramatically here in the next couple of weeks. Now, obviously, if this thing dies and the next one dies and the one after that dies, then yes, maybe, but at this point, probably would say it's a little bit slower than we anticipated. But given overall the environmental conditions look to be more conducive coming up, we would expect to see, stuff picking up pretty dramatically. Obviously, it doesn't, it remains to be seen exactly, because you can have systems that look like they're going to go and then they don't, and you can have there's definitely when we do these 2-week forecasts, I usually identify here's what we think is going to go and here's what we think is going to generate the integrated ACE that we look at for the 2-week period. And sometimes it verifies great. Other times we get the ACE we thought, and it was some other storm that we didn't even have, wasn't even on our radar. So right. it especially during the peak of the season, things will pop up in all sorts of random places. In addition to the waves coming off Africa, sometimes it'll skip basically areas that will spin up in the Gulf or in the Caribbean. So it kind of remains to be seen, kind of how things will play out. But one of the big things that I know we haven't talked about at all, I know we're kind of running out of time, but I do want to mention we talk about El Nino and La Nina and how that modulates vertical wind shear, which is that change in wind speed and direction with height in the atmosphere that really tears apart hurricanes. Mm-hmm. Another factor that is really important on this subseasonal time scale and can really be important for these ebbs and flows in the season is what we call the Madden-Julian oscillation. It was invented by two guys, Madden and Julian. One of my first talks in tropical meteorology was on the Madden-Julian oscillation, and sitting in the front row was Roland Madden. So that was a little intimidating. Yeah. Super nice guy, very, very complimentary. But when you're talking about an oscillation and the guy who discovered it's sitting right in front of you, it was a little bit intimidating. But anyway, he was a super nice guy. But really why that matters is because it alters where air is going up and down in the tropics. It's basically strong thunderstorm activity propagates around the tropics about every 30 to 70 days. So it's not like, okay, it's 46 days and it goes around. So that's with a lot of tropical things, it's kind of messy. Sometimes it's very strong. Other years it's pretty weak. This year it's been fairly robust. And right now, that oscillation has basically been enhancing vertical motion more over the Eastern North Pacific. And obviously, Eastern North Pacific was really quiet for about 3 weeks. Now it's obviously really busy there. As that oscillation continues to propagate farther eastward, that's why I've been talking about it should enhance vertical motion over Africa. And really, that's key. It's less about enhancing vertical motion over the Atlantic as enhancing vertical motion over Africa and the Indian Ocean, because one, it invigorates the waves, but really that's when you really lower the vertical wind shear. And Bill Gray, when he used to go to tropical discussion every day, would bring a 200 millibar map, which is basically like the winds at 30,000 feet. And if you see upper level winds blowing out of the west, that was usually a sign that the storm was not going to develop because it really ramped up your shear. So typically the Madden-Julian oscillation, when it's over Africa and the Indian Ocean, reduces your vertical wind shear. And that is really, usually the Atlantic is typically very shear dominant. So it's really marginal for shear. So when you lower the shear, you can get a really big season. When you ramp up the shear, you can really squelch the season. So the shear should be coming down. So this system right now, the shear is fairly low because it's pretty low latitude. If it were to track further north, probably wouldn't do much because the shear is pretty high. As we get later into September, the shearing factors that we see right now are probably going to be mitigated somewhat. So likely storms may be able to have a runway, a larger area that they could track would be in fairly conducive shear conditions.
Yeah, I think we're on a schedule that is similar to last year, actually, with the MJO. We talked last year about the Madden-Julian oscillation, the MJO, being in this conducive, supportive phase late September. We said when we get to the middle of September, it's going to be in that conducive phase. And looks like this year it's a similar sort of timing. And also last year, we were edging toward a La Nina in the Pacific in a similar way that we might be edging there this year. So, that's what I've been saying, that if you had to put money on it, you'd say the second half of the season will be busier. So to get back to the question about Phil's seasonal forecast, on balance, you would say, okay, just because the first half of the season was not half of it, that would not indicate that the forecast isn't going to be right. In fact, you'd probably expect it to not be half based on, what we've seen, and if all this timing works out in a similar way to last year.
Yeah, and that's what I can kind of finish with this one thing. Like, one of the things that we talk about with the seasonal forecast is because the Atlantic season is so peaked, variability in the Madden-Julian oscillation can actually be really critical. Like if you have a slow-moving Madden-Julian oscillation and it is really helping the Atlantic out at September 10th, around that window, you can get a lot of activity in that window. Whereas if you have this where like you had enhancing activity in say like early to mid-August and we got Aaron, but not much else, and then it comes around mid-September, that can be, just one of the things that not necessarily that'll completely break a seasonal forecast. So that's one of kind of the uncertainties because the Atlantic season is so peaked. Getting that timing either favorable for the Atlantic storms or unfavorable can be really big in terms of determining exactly how much storm activity you get.
Yeah. So, Phil, I know you have to go. So, thanks so much for joining us here this afternoon. And maybe we'll do this again later on in the season. We'll see how this season goes, and we'll talk about your seasonal forecast in a few weeks and see how it goes. But really appreciate you being part of this afternoon. You know, we're trying to replace the old way where people had to call in to talk to us. So now we do it on Facebook and YouTube and TikTok and uh, LinkedIn and Instagram and X. So we're spread across social media and appreciate you being part of it. So, all right, you take care and we'll talk soon. All right.
Thanks. Take care. Bye-bye.
All right. Be well. All right. So anyway, I'll hang around here for a few minutes. If you have any questions that I can answer, go ahead and let's do it, Jordan. If you have any more, otherwise we'll.
Yeah, so we
Wrap
got
up. All right.
we got some people joining in just now, maybe on their way home or something. A lot more questions about our future Gabrielle storm. If you want to talk about that.
Okay. All right. So let's once again, if we have new people tuning in. So here we're looking ahead here all the way a week, right? So this isn't what's happening right now. What's happening now is that the system out there is just developing. You can see where the reds are out there. That's the idea, is where it's most likely to develop. Now, and where is it likely to go? It's most likely to go toward these Caribbean islands here, looking a week out. Now, the odds, if you just look at the pure odds, notice here we have blues, and the blues are only in the 20 and 30% range, where over here we have the very high percentage odds. So the reason we have in this area here blues are a couple of reasons. One is that the possible tracks of the system kind of spread out. You can see some take it up here, right, and just turn it way north, others up in here. But the consensus is that it's going to go in here. But also a number of the models just wipe it out and say, no, this is going to dissipate. This is not going to survive the dry air that it's going to have to plow through. So we have, if you think about it, the way the models work is that they run, in this case, 130 nominally different models that we have made up of these three here. And so out of that 130, a certain number of them, a significant number of them, say, nope, the dry air is going to win and the storm is just going to fade out. Other ones say, no, it's going to find enough moisture, push back on the dry air, and it's going to turn into a significant storm. But the odds favor it. If you had to look at all those odds, you'd say not a terribly strong storm moving into the Caribbean. But you're talking about Georgia up in here. So what about Georgia? Well, there's just no way to know, because here you can see there's this big dip in the jet stream right there. Now, if everything else was not in the way, that dip in the jet stream would just turn this thing north, and that would be that. But nothing is that easy, because look at this circulation right in here. That's a pretty healthy high pressure cell. So that's going to want to try and block the system. So what's that mean? Well, if it gets, the high is going to kind of move this way. And so is that going to bring it up in here somehow? That's not impossible. And you can go look online and you're going to find models that actually bring it to Florida and bring it to Georgia. But you also find models that take it up over here. So we have this wide variety of possibilities. We also have low pressure right in here, by the way. This is a loft. We're all talking about a loft here. And that's going to, if the storm gets up a little farther north, that's going to want to tear it apart. So because this weather pattern in here is so unclear exactly how it's going to affect the system, we can't really say exactly where it's going to track, 10, 12, 14 days from now. So it's a long way out. For the next week, this is where we're going to look. We're going to look in this northeastern Caribbean area here, exactly how strong it is. That's just, if you had to put odds on it, where there's the best chance it's going, if it survives, is in that general direction. That's nothing about how strong it's going to be. It's nothing about anything about where might it go. And what I want to emphasize, and remind you of, let me just bring up this beginning thing here. If you haven't tuned in, this is the 90% chance that it's going to develop into at least a tropical depression in that area. But look at it close up over here as the sun is going down over top of it. It's only one little cluster of thunderstorms there. It's still tied up in this line of storms called the intertropical convergence zone. It's got to break out of that. So it's really too early to be paying attention to any models of a system that we don't even know where the center is. Doesn't really have a center. It's a strung out sort of disturbance at this point. We have lots of confidence that it's going to go in this direction, but really no confidence on what's going to happen 5 or 6 or 7 days from now. All right, Jordan?
Yeah, we can probably call this our last question here there. When will we have a better idea exactly where this storm will be heading?
Well, I think we're going to get a depression out of this Saturday or Sunday, if I had to pick right now. And once there is a center, which a depression means there is a center, that then the model's accuracy generally increases, especially if it's moving. The thing is, this is forecasting moving very slowly, so that's a negative on having some sort of confidence in the forecast. It's one of the factors, right? Disorganized, just organizing, or slow moving of having low confidence in the forecasts. So for a while, as long as this thing is creeping along, our forecast confidence is going to be low. So I would give it to the first part of next week. This isn't forecast to be, even at the islands. Now, the Google AI model, the DeepMind model, that moves it a little faster and gets it to the islands about Tuesday as a weak system. And even that one kind of dies out, has a significant possibility of it just dying out. Others take until Thursday or so. So somewhere in that midweek time frame is when it's forecast, if it survives, to be reaching the islands. So sometime over the weekend, hopefully, if it's going to develop, it'll develop a center, have something better to track, and perhaps we'll have better forecasts. So, but we'll see. We'll see. Anything that's slow moving like that is always very iffy. All right. So thanks very much for tuning in this afternoon. And really, this is kind of fun. And it was great to have Phil on. And he is such a star, as you can see. Phil knows a lot about a lot of things. He's my go-to guy. If I need something about hurricane statistics, Phil is indeed the guy. All right, so stay in touch with us on Fox Weather. Of course, if you're not sure how to get Fox Weather, you go to foxweather.tv, and it'll tell you how to get the Fox Weather channel on your phone, on your iPad, on your computer, on your TV. We're live and we're free everywhere that you might want to watch. So foxweather.tv will tell you how to do that. All right, thanks everybody, and have a good Thursday, and stay with us, and we'll keep on track of what's going on with this disturbance here as we move toward next week, which we think will be the more critical time. All right, take care. Have a good day.